Hi, my name is Taimur Adam, and for my CSE 335 project, I created an app called CampusBites. CampusBites is a location-based food finder app made mainly for students. The idea is that students are usually busy and may not always know what food options are near them, especially around campus. So this app helps users find nearby food spots, view them, filter them, and save places they might want to visit later. The main idea behind CampusBites is to make it easier for students to find food near their current location. The app lets users search for nearby food spots and filter them based on what they're in the mood for or what category they want. For example, a student might want something quick, such as a coffee, or be in the mood for a specific type of food. Another important part of this app is that users can save places to either their favorites or their wish list. Favorites are for places they like, and wish list is for places that they might want to try later. I wanted the app to feel useful for a real student because a lot of times students want something fast and something that's nearby without having to search through a bunch of random results manually. This slide shows the use case diagram for Campus Bytes. Let me move my camera. So the main actor is the user. The user interacts with the app by searching for nearby food spots, filtering results, viewing the food spot list, viewing places on the map, and opening food spot details. The user can also save places to favorites, save places to a wish list, view those save lists, and they can also rate a food spot. There are also external parts involved, such as core location and the overpass API. Core location helps get the user's current location, and the overpass API is used to get nearby food location data. Overall, this diagram shows the main actions that the user can perform and how the app depends on location and external food data to work. This slide shows the MVVM architecture for my app. The top section is the views. These are the screens that the user actually interacts with, like the home screen, the spot list view, spot detail view, save list view, and map pro view. The middle section is the view model. In my project, the food spot view model handles most of the app logic. It connects the views to the data and updates the UI when something changes. The bottom section contains the models, services, and managers. This includes things like food spot, save spot, location manager, overpass service, and Swift data. The reason that MVVM is useful here is because it separates the app into clear parts. The views are mainly responsible for showing the interface. The view model handles logic and state changes. The models and services handle the actual data. This makes the project easier to understand and also easier to update compared to just putting everything directly inside the views. This slide shows the capability of Campus Bytes. The app uses the user's location to find food nearby. It can show food spots on a map and also in a list so that the user has more than one way to browse. The app also allows filtering by food mood or category, which helps narrow down the results. Instead of seeing every possible location, the user can focus on what they actually want. Another capability is local storage. Users can save places to their favorites or their wish list, and the app stores those saved places locally. It can also store ratings for saved places, so the users can keep track of which places that they liked. The main goal of these features is to make the app practical and simple for a student to use. This slide shows some limitations and the lessons learned from this project. One limitation is that the location and some of the buttons can be inaccurate in the simulator. This made testing harder because sometimes the app didn't show the exact location that I expected, and also some of the buttons, such as the add to favorites and add to wishlist buttons, they weren't working on the simulator. So in order to work around this, I had to test on a real device, my own phone, because first it makes location-based features more realistic, and also just the app was functioning perfectly as expected on an actual device. Another limitation is that too many map pins can clutter the map. If the API returns a lot of food spots, the map can become hard to read. So right now I have set a limit of to show the nearest 25 food spots so that the map doesn't get too cluttered, but this is a temporary fix. That's something that would need better filtering or clustering in the future. The app also depends on external API results. So if the API doesn't return good data, or if there's a network issue, then the app's results might not be perfect. In terms of lessons learned, I definitely got a better understanding of Swift UI and MVVM. I also learned how to connect the UI, the app logic, location data, API data, and local storage together. This project helped me understand why architecture matters, because as the app grows, it becomes harder to manage everything if the code is not organized. For future improvements, there are a few things I want to add or improve. First, I would improve the UI design to make and also make the filtering feel smoother. Right now, it feels a little bit clunky when you're trying to filter through restaurants. The app works, but the interface could definitely be made cleaner and more polished. Second, I would add better sorting options like sorting by distance or sorting by rating. That would make the results more useful because users could quickly find either the closest place to them or the highest rated place. I would also want to add reviews or notes for safe places so that the users can remember why they liked a place or what their favorite food from that place was or why they wanted to try it in the future. Another improvement would be the map pin clustering for sure. This would help fix the issue where too many pins appear on the map at the same time. And lastly, I would improve the error handling for location and API issues. So the app gives better messages when something goes wrong instead of just failing silently or showing empty results. Now I will go through a little demo of the application. So here's the homepage. Um, if you scroll down a little bit, you can see the map. These are the closest 25 food spots near me. Um, I can click on Starbucks and you can add a rating, you can add it to favorites or add to wish list, and then it'll show up on these tabs right here. I'm not sure why on the simulator it doesn't work, but I just tested it right now on my phone and it was working on my phone. You can also use these quick filter buttons to filter. Here's coffee places near me. There's fast food restaurants. There's normal restaurants and there's dessert places. It's a little bit slow, sorry. I'm not exactly sure what's happening. My laptop really slow right now. I'm just gonna quit the simulator, but that was sorry about that. So let me bring the slides back. So that was the small demo of the app. It towards the end, I don't know, my laptop got really slow and it was freezing, but that's how the app works. So to conclude, Campus Bytes is a student-focused food finder app that uses location, maps, filtering, and local save lists to help students find and keep track of food spots near them. Through this project, I learned more about Swift UI, MVVM architecture, API usage, location services, and local data storage. There are definitely improvements I could still make, but I think that the project shows the main idea clearly and connects well to the architecture and the requirements. Thank you for watching my presentation.